This is the second video for section Stsd I and the last video for the module. Now, the regression equation. The relationship between two sets of data can be represented by a linear equation called the regression equation. The regression equation gives the variation of the dependent variable for a given change in the independent variable. It's extremely important to correctly determine which variable is dependent. The regression equation can be used to construct a regression line, or a line of best fit, on the associated scatter plot. Because the equation is for a line, the regression equation takes on the general linear form y equals mx plus c, or you might have seen y equals mx plus b. Usually, however, for a regression equation, this is written as y equals alpha plus bx, where alpha is the y-intercept and beta is the slope of the line. Determining the regression equation. Now if I have y equals alpha plus beta x, where beta is given by this formula here, and alpha is given by this formula here. Okay, the slope of the line depends on whether the correlation is positive or negative. A regression equation can be used to predict dependent variables from independent inputs within a range of the scatterplot values. It should not be used to predict an x given y, or to predict outside the bounds of given x values. The stronger the correlation between two variables, the better the prediction made by the regression equation. Again, a table of values with the following headings can assist calculations. So let's look at an example. Calculate the correlation coefficient for the height and weight data given. Now again, weight depends on height, so we have our x and our y. So from here we have to work out x squared and our y squared values. Sorry, not our x squared and y squared. Sorry about that. Our x squared and our xy values. So x squared is going to be 167 squared. And I won't fit that in, just to show you. So that's going to be 27889. X times y is 167 times 52, which is 8684. So next, we've got 178 squared, which is 31684, and xy becomes 178 times 63, which is 11214. So why don't you pause the video here and work out the rest of the values on your own. Okay, so you can see that I've filled in the rest of those values. I now need to sum each column, so the sum of x, the sum of y, the sum of x squared, and the sum of xy. If I sum each of those columns, I get 1697 for the sum of x, I get 563 for the sum of y, I get 288627 for the sum of x squared, and 96238 for the sum of xy. So that means my mean is going to be my sum of x over n. I'm going to run out of room, so I might come and put this over here. So mean of x is going to be sum of x over n, so that's going to be 1697 over 10 scores, which is 169.7. My sum of y is going to be the sum of y, sorry, I keep saying that. The mean of y is going to be the sum of y over n. So that's going to be 563 divided by 10, which is 56.3. So my beta is given by the sum of xy minus n, mean of x, mean of y, all over the sum of x squared minus n, the mean of x, all squared. So that becomes sum of xy is 96238 minus 10 times 169.7 times 56.3, all over sum of x squared is 288627 minus 10 times the mean of x, which is 169.7 all squared. Plug that in your calculator and you get approximately 1.08. Alpha is equal to the mean of y minus beta, the mean of x. So that becomes 56.3 minus 1.08 times by the mean of x. Now you should already have that beta in your calculator. So when you enter in this next line, go 56.3 minus answer, so you're using the exact value, times 169.7, and you get approximately negative 126.7. So the regression equation becomes y equals 1.08 x minus 126.7. That's because my regression equation is beta x plus alpha, or alpha plus beta x, same thing. Remember that in this case we haven't been given variable, so we don't have height as h and weight is w. If you are though, you'd have to use those variables, you can't just use x and y. So let's look at the next question. Use the regression equation to predict the following. So let's write what our regression equation was. So y equals 1.08 x minus 126.7. So the weight of a student who is 160 centimeters tall. Now remembering that height was x and weight was y. So here we've got that x equals 160 centimeters and we want to know what y is. So y is going to be 1.08 times by 160 minus 126.7, and that gives you 46.1 kilograms. So therefore expect a 160 centimeter tall student to weigh approximately 46.1 kilograms. That is approximate, remember we're just predicting here. So the weight of a student who is 175 centimeters tall, again you've got x is 175 centimeters, so you want to find y. Pause the video, give it a go yourself. Okay, so I've got y is 1.08 times 175 minus 126.7, which is 62.3 kilos. So you expect a 175 centimeter tall student to weigh approximately 62.3 kilos. Next, the weight of a student who is 185 centimeters tall. Well, in this case, it's exactly the same thing as what we've been doing. We've got x is 185 and we want to know what y is. Okay. Now the problem here is if we go back to our data, so we have a height of 185 centimeters tall. If we go back to our data, you'll see that our minimum height was 167 and our maximum height was 181. Okay. Now this 185 centimeters is outside the data range. Okay, so because it's outside collected data range, you cannot predict weight. Now I know that might sound weird to some people. Technically you can do it and it's an extrapolation, but it's not going to be very accurate because it is outside the data range, so just take it as in this course we don't extrapolate. Okay, the next one, the height of a student who weighs 65 kilos. Now we can't do this because we're working backwards. We can't work out height from weight. Okay, we can only predict weight from height. So just write. So I've just got cannot predict height from weight using the regression equation. Okay, what now? The exercise on this section is Stsd I2. We are at the end of the module, so you need to read the review, revise, complete Stsd K, and complete the module test. Also, before you do the actual module test, remember the sample test. It's a really good guide to see how you're going before you submit.